My name is Sean Rutledge. This is my email address at the Qt company, and I tend to hang out on these two IRC channels sometimes. You might be able to find me there. I've been a Qt application developer since about 2004, and I joined the Qt company in Oslo in 2011, and I've worked on a few things since then. Nowadays I'm one of the Qt Quick maintainers, and have worked on some other stuff too, but I've always been a bit focused on trying to get touch and Wacom tablets both working together better in Qt. The agenda for this session is to talk about the goals for what we want to achieve in Qt 6 to make input handling work better, the API changes that will help to make that possible, a bit about Qt Quick. There'll be a small demo. So the goals. In the past, we introduced this Qt mouse event source. So every Qt mouse event can say roughly where it came from in the Qt stack. Sometimes that wasn't enough information, because if it was synthesized, then we don't necessarily know whether it came from a touchscreen or from a Wacom tablet or something else. So every input event should always have a pointer to an object that tells you everything you might want to know about the device that it came from. We're intending to keep widgets, Qt Quick items, and handlers all working the same as it has been in Qt 5, of course. I want to be able to have a common event delivery code path for all QPointer events. We have already tried to do that in the Qt 5 series, but we did that by writing wrapper classes, which I'll show you more details about. You might already know about those. Flickable has always had some problems, and it never has handled touch, but I think that if we make the events look enough alike between mouse and touch, then we should be able to get Flickable handling touch directly without having to change it very much. And this includes the replay problem, because if you set press delay on a Flickable, then it will try to replay the original press event at a later time. This is so that if you have a button inside a list view delegate, you can delay a bit before you press the button. If the user's trying to flick, they're usually going to do it quickly. Wacom tablets, I always want to make some improvements, although in Qt 5 it wasn't bad. Eventually we'll try to go towards having multi-seat support, meaning that you can have two mouse cursors at the same time. And we're not promising to get it working very soon in Qt 6, but we're going to try to remove some of the obstacles. So the initial conditions, meaning where did we start from in Qt 5, the Qt Quick Pointer event is a QObject wrapper for QTouch event, mouse event, and so forth, and we have different subclasses for those different event types. That's because we wanted to prototype what the API could look like in Qt 6 and then go ahead and start using it in Qt Quick window for delivery. Qt Quick Event Point is a wrapper for QTouch event touch point, but every single point event also has one point. Qt Quick Event Point, because it's a QObject, it's easy for it to stick around and store state in between events, like which is the exclusive grabber, the usual grabber, the one that wants to get all of the events, and the passive grabbers, that's the new concept, which is you can have multiple items monitoring the position of that point at the same time. Qt Quick Event Point has a parent pointer which is stable, meaning that because the event queue objects are also pooled and reused, then they have stable positions in memory, so we're able to have pointers both directions. But it simplifies the delivery code. It's possible for Qt Quick window to deliver multiple event types with similar code. In Qt less than 5.8, this was a bit more of a mess. The event hierarchy is something that we haven't been able to change in Qt 5, but because touch events have multiple touch points, whereas mouse events do not, tablet events do not, and there was no common base class for any of these. The only base class is QInputEvent. Then we had to have three different delivery paths. So the green path shows how touch events are delivered, whereas a mouse event, you see this orange path. It will be dispatched multiple ways to these other functions over here, whereas QTablet event was not delivered at all in those older versions of Qt. The reason for this was that the event hierarchy looked like this. They have different APIs between the different event types. They're quite similar, but they're different. And then, of course, local pause, global pause, screen pause, window pause. We need to standardize all of those names. This was what the event hierarchy looked like in Qt Quick. We have these wrapper objects. So these are all Q objects. The Qt Quick Pointer event is the base class, and it has this consistent API that you can always ask how many points are there. If it's a mouse event, it's always going to say 1. And then you can access the individual point object by passing in an index, and you get back a Qt Quick Event Point star, which is this object. And this has the standard API for getting the positions and so forth. And we already had a mock-up of our device object too. So the delivery to handlers, this was when we formally introduced the pointer handlers for the first time. So of course all the events start with the QEvent loop. That's where it's actually getting it from the operating system. and then we send the Windows System events to the Qt Windows System interface, process a Windows System event on QGUI application, and that's where the dispatching starts. So we start with a Q Windows System interface private mouse event. That's a private event type which has been heap allocated over here in the Windows System interface and possibly queued, and then by the time it gets to the QGUI application, we still have a pointer to that heap allocated event. At this point now we have a stack allocated event, because when QGUI application received the heap allocated event, then process mouse event created a new Q mouse event, and that's the thing that it's sending over here. So we have a mouse press event coming in QQuick window, and then we wrap that. We do that by querying to see whether we already have one. Usually we get an existing instance that we already have, and so we just populate the Q mouse event pointer inside the wrapper, and that's what this reset function does. We pass in a Q event, and now it becomes a wrapper for that event that we passed in, and then it in turn calls reset on the QQuick event point, which is the one point inside the mouse event that remembers the positions and stuff. At this point we're doing pointer event delivery. So we have this pointer targets method, which is recursive, and its job is to return a vector of all of the items that are underneath the point. Because we're starting dispatching to handlers first, because they get priority over the old item-based event dispatching. So for each handler that is registered on the item, meaning it's a child of the item, we ask, does it want the event point? If it does, then we call deliver matching points to item, which actually calls handle pointer event on the item private, and that will in turn call handle pointer event on each of these handlers. So in this example we say that there's only a drag handler. We're doing a drag here. And then it will call handle pointer event impl, which is just a private function in the handler. Let's say, yes, the drag begins, and at that point it becomes the grabber, and it also calls set accepted, which means not only is it the exclusive grabber, but we're done with delivery. We don't want to do any further propagation. So in Qt 6, we have now refactored the event hierarchy to look a lot like the QQuick event hierarchy. So we have our Q event, we have QInputEvent like before, and now we have a new subclass, QPointerEvent. So this one has this uniform interface now, point count, and we're thinking probably we'll also return a QList by reference, because that's how the storage is done. So that way if you want to write an int-based for loop, you can use point and point count. Sometimes that works better because we're thinking that maybe this will be the non-const interface in case you need to modify the event point, meaning you need to call set exclusive grabber or something like that. But then the QList interface is going to be const, but that one's better for doing range 4. So it seems like probably we should have both. And then yeah, these events are basically untouched. QFocus event and QKey event haven't changed. Okay, but the subclass of QPointerEvent, we have a single point event, which is most of them, because like a mouse event can only have one point. And it also, we assume that all those single point events deal with devices that might have buttons, like mouse buttons. And these accessors are just there for the legacy code to keep it working, because you might not really want to change your code to do the indirection to get the individual point and then get the position out of there. So you can also just get the position from the event itself. And then we have QTouchEvent, and it has this legacy accessor touch points, which already was going to give you a list of QTouchEvent touch points, but now those are QEvent points, and that's deprecated because it's the same as this function points. It just returns a list of event points. But this will allow you to make very minimal changes to your code in order to port it to Qt 6. So then we have the subclasses QMouse event, hover event, tablet event, enter event, wheel event, and native gesture event. All of those are things that have positions, and some of them have other stuff, like the wheel event gives you the angle deltas and so forth, but it also tells you where the cursor is. So that's why those inherit from single pointer event, so that you have this point object, and then the interface is very uniform now. All of the events look alike. But anyway, a pointer event is going to have one or more points, and so those are the QEvent point objects, which we store in an impoints QList internally, and then we simply return that reference to that list in this accessor. So the standard interface for positions now, we have the position, the scene position, and the global position. That's it, and that's always the same name. But it also remembers some historical positions for historical reasons. It can tell you the because that's how we were doing it in Qt Quick. Global press position, it remembers where was the mouse at the time that you pressed, or the finger. Where was the mouse or the finger at the time when the last exclusive grab was done. Both these are all available on all the coordinate systems too. We have the local, the scene, and the global positions. And then pressure, rotation, those might not always be interesting, but they're there just in case. And also, every point has velocity now, so you always know how fast it's moving in addition. And then ellipse diameters is specific to touchscreens. It's basically if the touchscreen hardware is able to tell you how big the area that your finger will be in contact with, then you can get that information as well. Most devices don't do that. So there's kind of two ways to get pressure. There's pressure itself, and then there's this ellipse diameters. And associated with that, you might have rotation, so that the ellipse is actually rotated according to how your finger is on the screen. But I've never worked with a touchscreen that can do that. I wish I had one of those. Every input event has a device. So the base class is QInputDevice. So even a keyboard, there should be an instance of one of these. Assuming that the QPA platform plugin actually registered the devices, that's its job. It's supposed to detect all the devices, and it's supposed to, for each one, call QWindowSystemInterface, register input device, and pass in a new instance. And that's how it becomes known to the GUI layer. So when you get an event, if the device didn't already exist, it's going to create a dummy device just to make sure that there always is something there. And then that will tell you the name, the seat name in case you're on Wayland and you have multiple seats, or in case you have multi-pointer X11 like I do. Then the seat name should be unique for each of those seats. The available virtual geometry tells you what part of the desktop this device is mapped to. So for example, if you have several screens but only one of them is a touchscreen, then that will tell you the rectangular area that the touchscreen covers on your whole desktop. You can also get a list of all the devices, so that's useful for tools like QtDiag. We've already updated it to get the list of devices there and show them. And then there's primary keyboard, which is like if you need to create an event and you don't know which device it really comes from, you can just say, well, it's the primary keyboard, whatever that is, and it will figure it out. Then we have a subclass QPointingDevice, which also has primary pointing device, which is a similar function that will just figure out if there's only one mouse or if there's several mice that move together, then we just say, okay, that's the core pointer, and we return that as the device. QPointingDevice also provides a grab changed signal, set exclusive grabber, add or remove passive grabbers. You call these functions on the QPointer event now. You pass in the point instance that you are grabbing, and the result will be that it will emit this grab change signal, which tells you specifically which point was grabbed or ungrabbed, what the transition was it getting a passive grab, losing a passive grab, was it getting an exclusive grab, and so forth, or was the whole thing canceled, and also which object became the grabber. So this signal is very useful to QQuick window to be able to track what's going on and to tell the item or the handler that it got the grab or lost the grab. Okay, so we'll talk about the internal design decisions in a minute, but what you can see here is that the QEvent point, I really didn't want it to have a D pointer because I thought that it would be lightweight if it didn't, if it was just a really self-contained object, but we had a API review with Lars and he really thinks that we should keep the D pointer, so we went back to having a QEvent point private, which is manually ref counted with an int, so it's not an atomic int, it actually is faster than that, because we're not really expecting these points to be moved across threads. The dispatching is always done on the same thread anyway, in the GUI thread. And then it has the data storage for all of these accessors that you see here. There's a subclass QMutableEventPoint, which is only for private use because we really wanted to avoid having any setters in any of the events or the points that the users are not supposed to call. So, for example, QTouchEvent touchpoint had setters for everything, and that was silly because the users don't need it. It was basically just there for the QTestLib to be able to generate tests and modify those points and then send the events. So we kept all of our setters private by making subclasses. And so if you actually include GUI private in your PRO file or your CMake file, then you'll be able to use those as well, but you shouldn't need to for normal applications. So the hierarchy looks complicated compared to Qt 5, but it isn't really. It's just a couple more base classes in between there so that we classify our event types a little bit better. So delivery to handlers in Qt 6. Basically, the difference is that we start pointer event delivery a bit earlier than we did before. It's not just in QtQuick, it's everywhere. So we again start from event loop, Windows System Interface, GUI application. We got the heap allocated QPA mouse event. And then, well, the first thing that happens is that the Q pointing device, I forgot to mention that each device has a QFlat map with the active points, and this is where it stores your persistent data, meaning if you grabbed a mouse press, then the reason you did that is because you want to get all the updates, right? So we're not just going to throw this information away and construct a new Q event point every time. Instead, we keep this event point data object, which has passive grabbers and exclusive grabbers, and possibly anything else that we want to keep in between the events. And actually, right now, it actually has a copy of the Q event point itself, except the Q event point isn't a copy because it has a private. So it's just incrementing whenever you have an event being delivered, your ref count is 2 because you have one instance being stored in the event point data and another instance that you're actually delivering. When the event comes in, we first ask the pointing device for active point, and let's say this is a mouse event, so we know it's always active point 0 because we always use 0 for the ID, for the point ID inside a mouse event. So it will return that instance that it has, and then we're constructing a Q mouse event, and we're constructing an event point kind of, except it's reusing the D pointer. And then we call process mouse event, call notify. At this point, we're delivering a pointer event now. And eventually we call event on the window, and it does all the same stuff it did before, except now it doesn't have to wrap with the QQuick event point wrapper or the QQuick pointer event, because it already is a pointer event and it has the same API. So we just have to make some changes to QQuick to actually deal with those original events directly, but the API is the same, so that's fairly easy. And then after the delivery is done, it's been accepted, therefore all of the points are accepted inside the event, then we're done with it, so we throw it away. The event point that we delivered and the QMouse event will be destroyed, and then the ref count goes back to 1 because we still have it stored in active points. So the initial conditions in Qt GUI, meaning where did we start with Qt 6, touchpoint is heap allocated and has a pimple. QPA events are these unrelated, mostly duplicate classes in Qt 5. And those are also heap allocated, but that's because they have to be potentially put into an event queue, so they can't really live on the stack. Whereas input events are stack allocated in Qt GUI application, and they go out of scope after delivery. We already went through these problems pretty much, that the subclasses have duplicated but incompatible API. The design decisions that we went through, we started with the initial conditions on the previous page, and then we knew that we wanted to introduce QPointer event. That was the whole reason for prototyping it in QtQuick, was to make sure that that was going to work. If we didn't do that, then we wouldn't be able to have the unified delivery logic in QtQuick window, and therefore we wouldn't be able to stop using QtQuick wrappers. But I wanted to get rid of the wrappers because that's quite some overhead to take every event and wrap it in another event before we can deliver it. Next decision, should every pointer event have multi-point API? Yeah, that's the whole point. We're going to have point 0, and the point accessor, you get a Q event point now instead of a QQuick event point. Next question is, where should we actually store the event points? I wanted to have point count and point int I be virtual functions, and that way the single point event would be smaller because it knows it only has to store one point, and the touch event would have a Q list. But on the other hand, we have this points accessor, and it needs to return a Q list anyway, so it turned out that that was kind of silly. So we just decided to move the Q list of event points up into QPointer event itself. The next thing is that Q event point, should it have a pointer to the event? Because in QtQuick, we did that with the wrapper events before, that every point knew which event that it came from, and therefore we were able to deliver points by themselves without having to always pass the event along with it. So that was handy, but on the other hand, the events would end up not being movable because then the points would be pointing to the wrong event, and so that would have required some bookkeeping, and I started to think about how to do that, and then I said, no, I don't want to do that. So the result is that we have to change some things in QtQuick because we're always having to pass them together now. You get an event, you're interested in one point out of the event, you have to deliver it together. So some functions take 2 things instead of 1. Next question is, shall we hold the Q event point state in the pointing device? Because it seems like if you try to think about real-world modeling, the hardware and the driver probably remember where your fingers are on the screen at all times. So we want to model it that way in Qt as well. If we didn't do that, then we'd have to just keep doing it the way it was in Qt 5, that there were some ad hoc structures in QGUI application. There was a QHash or something that mapped the touch point ID to some data structure. And the mouse data was stored as if there could only ever be one mouse. And so we really want to have multiple seat support. Next thing is, do we want to put the event point instances in the events by value? The alternative would have been to put pointers inside the events. And, well, if we weren't going to have a depointer, this is an earlier part of the decision tree, so this was before we decided that event points should have depointers. To avoid copying, we could just have a queue list of pointers instead. The advantage is, of course, that the event is lightweight. Events couldn't be saved and replayed directly because notice when we went through the sequence, every time a new event comes in, the active point state gets updated right away. And so if you're trying to replay an event, but your event that you're going to replay points to a point that has since been updated, then you've lost the state that you were going to replay. So that was basically the Achilles heel. That was why I can't use pointers for storage. But the nice thing, of course, it would have been a smaller change for Qt Quick API because it was already that way before. And so back when I was going down that path, then I tried to think about how would I change the storage so that this could work. So one idea was to do it like a coat check at a restaurant or the opera or wherever. You drop your coat off at this desk and they give you back a token, and then your coat can sit there for a few hours or whatever, hang on the hooks, and then you come back and give them your token and you get your coat back, right? So I thought, well, I can do that with event points. I can still do that by value, so it doesn't involve the heap. And then the event could just have a token to keep track of which event point it's referring. When you have an event that you're saving for later replay, it would just keep track of the token, and then it would go back and get the event point at the time that the replay happens. But then the troubles are, I had to modify too much code, and then I realized that this save and replay stuff is actually more pervasive than I thought, because QQuick window is doing that all the time because of the way it's doing touch event compression, meaning that if your touchscreen is really high resolution, you might be able to have a lot of little micro movements that happen in between frames being rendered. So you might be delivering touch move events 10 times in a row before you finally get around to rendering a frame. And so to avoid the performance impact of that, we do this compression thing where if the only thing that's happening is touch moves, then we just compress them all into one event and send it later. But the thing that triggers the moves to be sent is quite often a release. So that's where this problem comes up, that the touch release already happened, we've updated our event point, and now we try to replay this old move event, but now it doesn't say that it's a move anymore. It says that it's a release, and that doesn't work. So I would need to use the coat check every time. And then there's the replay in Flickable, which I still haven't gotten around to yet, but pretty soon I've got to get that working. It's mandatory. And then I discovered also that even Graphics View is doing some replay. So I thought, there's too many of these places, and probably there's user-written code that is copying our ideas and doing it the same way and expecting that, you can construct a QMouse event, you can keep it for as long as you want, and then you can send it through the application at a later time. So events need to be self-contained, which means we can't be storing pointers to event points, which will change underneath you. So back to storing instances inside the events. That way they're copyable, save and replay works. But the bad thing is that it means we have to copy some stuff back and forth to the persistent instances because we still need those, because we still want the device to remember the state for the long term. The next thing is, do we want to use QGadget declarations on the Q event point and the QPointer event? I think we do, because that means that we can emit those by value. We can emit from C++, and then you can actually have a signal handler in QML that can receive the point and can see all of its properties. So yeah, we need the gadget declaration, and there's nothing really wrong with that. It's too bad that we can't do it by pointer, but unless we were to actually make those touch points be QObjects, then you just have to get by with gadget. But again, depointers make it so that even if you modify a property, like you said, accepted to true, maybe we can make that work. But if we can't make it work, then we're probably still going to have to keep this QQuick mouse event, because that's the old use case, is that in a mouse area you can actually accept and reject the mouse press, and that determines whether you're going to get the updates. And then we had this discussion where we decided to reintroduce the depointer. So the disadvantage, of course, is that we're doing heap allocation, and of course every accessor has an indirection. We really like events to be small and for accessors to be efficient, and they should just be so small that they're cheap to copy, right? That was how I wanted it to be. But actually, QEvent points are kind of heavy because they have to store, 7 different positions and some other stuff, velocity and so forth. So we're going to keep the depointer because that gives us the usual freedom to change the implementation later on. And copying is quick because you just increase the ref count and you're done. And also QPA events are heap allocated. We don't seem to be able to get away from that. So maybe we should just have the platform plugins create the QEvent points, and then we could just keep them and pass those all the way through. And then it would end up being more efficient than Qt 5. Well, all of this stuff is more efficient than Qt 5. The question is, how much can we push it? Next thing is, should we store the grabbers separately? Because now that we've got the depointer, the QEvent point private can store the list of grabbers, and that doesn't really cost very much. But on the other hand, those are being created and destroyed every time we're receiving a new event. So we decided to move that to this event point data object, which is stored in the QFlat map and QPointing device. It's too bad to have a separate map structure, because I was hoping to avoid doing this lookup, where is touch point number 4? I have to go through the map and find it, and that's being done frequently. But the advantages are that the QEvent point private is read mostly data and disposable, because most of that state we don't need to keep, and it's smaller because we don't have a queue list of passive grabbers in there. But anyway, here is some example code for how to handle events in an agnostic way. You receive a queue event. You want to check, is it a pointer event? So we have an extra flag in there so that that's really cheap. It doesn't involve doing a dynamic cast. And so if it is a pointer event, then you're allowed to static cast to a queue pointer event. And now you can check, is it a press event? And then you can simply go through the points. There might only be one. Probably there's only one, but there could be more. So you just go through the points, and then you have some way to react to a press at a particular position. And if the reaction was successful, then maybe you want to set the exclusive grabber to this, whatever this object is, because you want to receive the updates. So this is how to write really simple event handler code that will work with touch and tablet and mouse all the same. Another snippet about how to check whether it's a synthesized mouse event or not. Well, there are multiple ways to do it. The oldest way was to just check whether the event is spontaneous or not, because if it was non-spontaneous, that's supposed to mean that it's synthesized. But that ended up being kind of vague. And so we came up with this Qt mouse event source in Qt 5.4. So a Qt mouse event, you can ask for the source, and then you can check whether the mouse event is synthesized or not. And if it was synthesized, was it by Qt or by the OS or by the application? But then if it was synthesized, you don't know if it's from a touchscreen or from a Wacom tablet or what. But since 5.10, in pointer handlers, you've been able to set accepted devices to just the devices that you're interested in. So that's a declarative way to make sure that you only get the events that you want. But if you are working in C++ now, in Qt 6, you'll be able to ask for the events pointing devices type, and then you can check, is it a touchscreen or a touchpad, if you want to find only events that come from those two device types, or it can be a tablet. And now we've got this slightly redundant API, which is the pointer type. And the real reason why that is there is because a Wacom tablet, well, not every stylus, but most of them have an eraser on the other end. So we have stylus and eraser as two pointer types. So just to make it consistent and kind of fill it out, we have a few more pointer types too, like finger. So if you want to check whether something comes from a touchscreen, you have two ways to do it. You can check the pointing device type, or you can check the pointer type to see whether it's a finger, and then you don't care so much about the device itself. But we're thinking that that might be a bit too redundant, so we might actually take this out before the release. And okay, so this is a Qt 5 style example. It's just been slightly modified for Qt 6. So I have a point handler, which means that it can only handle one point, and we don't care which button is pressed. We want to handle them all. And then I'm going to draw crosshairs on the screen, and I'm using some properties out of there, like rotation. So let me do this on my Wacom tablet now. I'm moving the cursor, I press, and now as I rotate the stylus, you can see that it rotates this item as well. And you also see that the seat ID is there, 230022. That's something that's generated by the X11 XEB platform plugin, because X11 doesn't have API for setting a specific seat name, so we just make them up in the platform plugins based on the IDs. We figure out which devices are connected to each other, and then the master, a combination of the master ID becomes the seat name. And you can see which specific device. It's a Wacom Intuos 3 tablet, and it's a pin stylus. And it has its own UID. That's a unique serial number for this stylus. So if I was to use a different stylus, it would be different. So this is now there's a bug in the rendering, and I don't understand. I don't think that's part of Qt that causes that glitch. I think it's my Windows system or NVIDIA drivers. I don't know. So I'm using all this stuff down here. Point handler gives you a point object, which is actually a QQuick handler point that just kind of copies through all the stuff that's in the event point. So you can ask for the device then, which is the Q pointing device, and you can get its seat name. You can also get the device name, the unique ID from the point, and all this other stuff. And so I put this piece of text together. There's also a velocity vector, so if I move the thing fast enough, then you'll see vectors sticking out to show you how fast it's moving. So I mentioned that I have two mice on the system, right? So if I press with my mouse, it simply says it's the core pointer and there's no seat, and that's a bit wrong. There's something wrong in the platform plugin. Now I have a second mouse connected here. Notice there's the right mouse, here's the left mouse. I'm pressing and dragging. And this one also says it's a core pointer with the same seat, and that's wrong. They should be different. So this is something that needs fixing before release. Okay, but just to make it interesting, now you can see me do this. Oh, except the camera went away. Okay, it's upside down for some reason. Rotation is wrong. But at least you can see this one is different. 30002 is the seat. That's coming from the platform plugin. It actually knows that this is mapped to a different seat. So then let me show you how this looks. Okay, when I started my presentation, you know, there's this code that always dumps all the input devices that it finds. So now you can actually see different seats as they're discovered. So there's 230022 and there's 30002, and it shows which devices are on which seats. And now if I run QTiag, you can see the same stuff. So this is not actually labeled as a seat name yet. It really should be. And now I have this Microsoft mouse as my second seat. That's the auxiliary one. Whereas my main keyboard is on this 30002. So how did I do that? It was like this. X input create master aux, meaning this is the auxiliary seat, and then I reattach certain devices to the aux pointer and to the aux keyboard. So that's how you set up multi-pointer X. If you're doing it in Wayland, then it's a little bit different configuration, but Sway, for example, is able to do this kind of stuff, and then you can have multiple seats in Wayland as well, which is really what it's for. So that was the demo. Sorry, it's nothing more fancy than that. We'll get it working better later on. Stuff left to work on. We need to make Flickable work better. There's always been this velocity problem, and I think that since the points have velocity, we should be able to just use that directly to drive the Flickable behavior, so we don't have to recalculate velocity in there. And that's one of the reasons I wanted to always have velocity, to make sure that that works. Then we can simplify Flickable. It needs to do the event replay like we talked about. If it's a touch event, it needs to replay that instead of a mouse event. Q pointing device we might rename to Q pointer device because we have Q pointer event, so it's a little bit confusing the way it is right now. Pointing device pointer type, that's the thing that we need Wacom styluses to identify whether it's the stylus or the eraser, but the rest of that's kind of redundant. And there are actually other things to work on, which this list isn't all that complete. Well, we're going to try to keep it working about the same from the user perspective as much as possible. So that's it. Thanks for watching. Hope you enjoyed it.